Good morning, students. Today we can discuss two problems based on bearing capacity. First problem: a square footing 2.5 meter by 2.5 meter is built in sand, having unit weight 20 kilonewton per meter cube and phi angular shearing resistance 36 degree. Depth of the footing is 1.5 meter. Calculate safe load that can be carried by footing with factor of safety 3 against shear failure. Assume general shear failure. And NQ is 49. It is given that NQ is 49.4 and N gamma is 54. Okay, so this is the problem. So it is a square footing and a general shear failure condition. So first write down the equation for a square footing, that is QU is equal to 1.3 CNC plus QNQ plus 0.4 gamma B N gamma. It is the ultimate bearing capacity for a square footing. In some textbook it will be 1.2 instead of 1.3, it will be 1.2. Both are small difference will be in the final answer only. So both equations are same. Next, since this is a sand, quotient value will be 0. Okay, so equation becomes QU is equal to, first component will become 0 because C is equal to 0. 0 plus QNQ plus 0.4 gamma B N gamma. And what is Q? Q is the surcharge component, and Q is equal to gamma into dF, unit weight of the soil into depth of footing. And you substitute all these values, all values are given. So Q is equal to gamma dF, that is 20 into 1.5 is the depth of footing, into NQ is given, then 0.4 gamma B N gamma, and final answer is 2562 kilonewton per meter cube. Okay, so that is the final answer. Next, here we have to find out, so what's the question? Calculate the safe load. Okay, so we have to find out the safe load. Factor of safety is also given. So next step we have to calculate net ultimate load, QNU. Okay, then net safe load is equal to QNU divided by factor of safety. So QNU is equal to QU minus gamma dF. So 2562 minus gamma dF have to calculate it, and divide that QNU by factor of safety. We will get QNS, net safe bearing capacity, QNS 844. It is obtained as 844 kilonewton per meter cube. Then gross safe bearing capacity is equal to QS, which is obtained by adding the surcharge component, that is QNS plus gamma dF. So these definitions we have studied in first lecture of this third module. Okay, so that all the terms should be by hearted, all the equation, all the relationship extra, that is ultimate bearing capacity QU, that is the equation derived by Terzaghi. Then QNU is equal to QU minus gamma dF, and QNS is equal to QNU by factor of safety, net safe bearing capacity. Then QS, that is gross safe bearing capacity, is equal to QNS plus gamma dF. Okay, so here we have to find out the safe load. We have to calculate the safe load. Okay, so if we want to calculate the net safe load, we have to multiply the net safe bearing capacity with area. And if we want to calculate gross load, multiply gross safe bearing capacity into area. Okay, so that is the procedure. If we want to find out the load, we have to multiply with area, because this is a pressure. Okay, so multiplying this pressure with area will get a load. So net load is equal to QNS plus A into area, that is 844 into 2.5 square, because it is square footing. So A square. Next, gross load is QS into area. So this is the procedure. Okay, so next problem. Next problem is based on effective water table. Okay, that is in last class we have studied the effective water table on bearing capacity. Okay, so problem: a strip footing of 1.5 meter wide is at a depth of 1.2 meter from ground level in sand. So phi is equal to 40, NQ 81.3, N gamma 100.4. Calculate safe bearing capacity assuming factor of safety is equal to 3. When A, water table at footing level, B, water table at ground level. That is, here there is effective water table, and we have to find out the safe load, safe bearing capacity when water table is at footing level and water table is at ground level. and unit weight above and below the water table is given as 18 and 10 kilonewton per meter cube respectively. Okay, so since it is strip footing, first you write down the equation, that is Qu is equal to Cnc plus Qnq plus 0.5 gamma b and gamma. And first we can do the first case in this problem, that is water table is at a footing level. So you draw the rough sketch, that is this is the footing, and depth of footing is given as 1.2 meter. So marked, so the depth means a distance between ground level and the footing base. Okay, then here water table is at footing level, so water table is here at this point, so water table is marked like this. This is the water table. Okay, then initially write down the equation, that is Q is equal to Cnc plus Qnq. Q means gamma df into nq plus 0.5 gamma b and gamma. And I have told that in the previous section, if the water table is at footing level, ground level, etc., we have to consider the unit weight accordingly. That is, here water table is here, so the soil below this water table, that is soil at this portion, will be in submerged condition. Okay, that is the third term, that is the third term is the component of this unit weight component. So in the third term this will be gamma dash. Okay, because the soil is in submerged condition, that is this portion constitute the second term and this portion constitute the third term. So this portion means second term, means here there is no effective water table, so in the second term gamma itself, it's not submerged, it is bulk unit weight. Okay, so Qu is equal to Cnc Qnq plus 0.5 gamma b and gamma, and substitute in this equation. Then Qnu is equal to then net ultimate bearing capacity is equal to ultimate minus gamma df, and it is obtained as 2487.48 kilonewton per meter cube. Okay, then we have to calculate safe bearing capacity. So we have to calculate Qnu, net ultimate bearing capacity, and Qs, safe bearing capacity, and gross safe bearing capacity. Okay, so Qs is gross safe bearing capacity is equal to net safe bearing capacity plus gamma df. Net safe bearing capacity is equal to net ultimate bearing capacity by factor of safety plus gamma df. Okay, and the final answer, that is gross safe bearing capacity is 850 kilonewton per meter square. So that is the case when water table is at footing level. Okay, and the second case, the water table is at ground level. So here is the water table at ground level. So in this case the whole soil will be, that is the soil below this water table will be in submerged condition. So the second term and third term both constitute the submerged unit weight. Okay, so in this equation second term also gamma dash and the third term also gamma dash. So that is the procedure. Then in similar way you do the steps. Okay, so the final answer is 584.2 kilonewton per meter square. So this is the simple case of water table, that is here water table is at footing level, and in the second case water table is at ground level. So in that case you check whether the soil is in submerged condition or the soil is in normal moist condition. Okay, so the soil which is below the water table will be in submerged condition, and the soil above the water table will be in normal moist condition. So likewise you substitute as bulk unit weight or submerged unit weight. Okay, so that is the procedure. So this is the simple problem based on the effect of water table. So if you have any doubt, please contact me through WhatsApp or you can call. Okay, you should do more problems from the textbook. I will try to solve some more problems in the next video. Thank you.